Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. Hackett enables developer-led companies to deploy physical infrastructure at global scale in under 60 seconds. With 18 plus public cloud locations, as well as private deployments and on-premises software solutions, Hackett helps make infrastructure a competitive advantage.
Hi, it's B. Cameron Gain, correspondent with the New Stack, and I'm here today with Matt Taylor. He is Senior Vice President of Worldwide Sales and Business for Ampere, the server component processor maker. Thanks for joining me.
Yeah, thanks for having me.
And so, what is Ampere, and what led you here as far as your career journey goes?
Yeah, good question. So Ampere's kind of an interesting company. So we like to say we're not your normal startup. So we're a 2-year-old company now. We're actually formed through actually buying another ARM server company. So we've got a company called Applied Micro that had done multiple generations of ARM server processors.
They've been around for a long time.
Yeah, and they had kind of separated their business. They had a networking side of the business and an ARM server business. And long story, but they decided to actually sell the company. And we had the opportunity to actually come in and acquire them. But it wasn't just a random company that we decided to buy. The actual founders of Ampere, which was Renee James
of Intel.
Yes, former president of Intel. She had retired from Intel, was working at Carlyle Group and looking at different media and technology investments for them. And she had, even before she left Intel, had this idea of, look, there is a need for a different architecture, really a different architectural approach for what is cloud going to need in the future.
And why did you decide to join there? Where did you come
Well, actually, kind of an
journey?
interesting background. So I was also ex-Intel. Spent about 15 years in Intel, pretty much all on sales and marketing, business development sides. But I spent the last 5 years of Intel actually running Amazon account. And so, I mean, really interesting experience that I saw AWS grow from what people really didn't know what it was. It was like, no, they're a retailer. No, they're actually
It's Amazon.
Yeah, it's Amazon. And from that perception to this is the world's largest cloud company. And I saw that transition happen. But going through that, I really saw this need that they were recognizing that just general purpose silicon that was built for everything from basically PCs up to HPC computers was not really what they needed. And actually, one of the main reasons why I ended up leaving was they bought a company called Annapurna Labs, which maybe you've seen a little bit of now. Annapurna was Amazon's first venture into building their own silicon. And I saw this, and the main reason why they did this was they needed to actually go and have different silicon than what they were going to get from the incumbent suppliers. And so I saw that as this is really a direction that the market is going, and ended up through a couple of different journeys, ended up in Ampere because Ampere has a kind of unique mix of what they have. And like I said, we'd like to say we're not your standard startup, right? We're now about almost close to 600 people. 600, yeah. So, which is still small in Silicon World, but it's not tiny. But I mean, it's more the makeup of the people. So we have this team from Applied Micro who came over. They had done multiple generations of ARM processors, and then we supplemented this team with some just pretty amazing industry veterans. So our chief architect, Atik, is here actually giving a talk right now.
Oh, nice.
Atik was the chief architect for Intel, basically silicon, for the last 10 years he was there. And so we got him.
What was his baby as far as the processor goes?
He did everything from actually PC, Pentium, all the way up into, he was working on Xeon for the last couple of years.
He led Pentium and Xeon.
Yeah.
He's with you guys
Yeah,
now.
it's like basically the P4 team, the team that did P4, the majority of those people now are at Ampere.
Because every developer, they're not necessarily interested in crunching metrics for
Yeah.
hardware performance,
Yep.
but they obviously know Penron, they know the different Intel
Yeah.
processors, et cetera.
Yeah.
And it's becoming more important, or what's becoming more important for developers as well is how can we squeeze more performance for applications out of the processor
Yep. Yeah.
stack
Yeah.
or configuration. So I'm just wondering where does ARM come in, or why not just play with the configurations of Intel
Yeah.
or AMD, or combining the two,
Yeah.
if that's possible,
Yeah.
or why did you decide to go with ARM, or why?
Yeah, I mean, when we formed the company, we looked at a lot of different options, and doing an x86 processor and getting a license for x86 is very challenging. We decided that we didn't want to spend our entire lives in legal discussions, and so we looked at what else was out there, and we looked at a lot of things. And
Yeah.
really, the reason why we chose to go ARM was the robustness of the ecosystem.
Mhm.
And if you look at the challenge of this industry. Actually, building high performance silicon is hard, but we're not the only people that can do it.
Yeah.
We think we have a unique team. We think we have a lot of skill sets that have done this at scale. But really, for us to be successful, we need to have a robust software ecosystem, and there needs to be multiple people contributing to that.
And that's
And
where
that's where ARM comes in.
and the open source component is
Yeah.
huge at the same time.
Yeah, exactly. I mean, so we chose ARM as our architecture because frankly, we looked at it and said they have the most robust ecosystem. There's risk out there, there's power out there, all of which we could have done.
Yeah.
And we basically said, who has the most robust ecosystem and who is investing in that ecosystem to make it come to fruition. And then the second element was really what you mentioned, which is the investment in open source silicon or open source software, because ARM has such a large footprint from a mobile, IoT, automotive perspective. The software that's being developed there, the basis is a lot of it's the same open source basis that you're using in servers. And
Wow.
so you look at that and we said, okay, the fundamentals are there. Right? I mean, I wouldn't say everything's there from a software perspective.
Yeah.
There's still work that will need to be done. But if you look at any sort of cloud or edge stack, what they're running, it's all available on ARM and it's all been optimized. Your OSs, your hypervisors, your containers, all the way up into databases and storage stacks and all of that. It's all there for ARM. And so that was really one of the big reasons why we decided to go on to ARM architecture.
And for those not necessarily in the know yet, why is ARM, or how can it be, or how is it different from a developer's perspective? I mean, you're designing applications or code, creating code, for example, that are to run on servers or IoT devices, for
Right.
example, whatever. Why should they care or even worry about whether it's an ARM configuration or an x86 device, for example?
Ideally, we don't want them to care.
Yeah.
I mean, that's actually the goal we want to get to. One of my good friends, John Masters, used to be over at Red Hat, and he used to say, my goal is to make software boring.
Yeah.
And I want to make this so you don't have to think about it.
Just like they want to make Kubernetes boring.
Yeah, I mean, it's very similar, right? I mean, it's you really shouldn't care, for us, what architecture you run on. Now, obviously, there'll be things that you have to do to optimize things. What we really want you to spend your time on is don't worry about how it runs. It should just run fine. If you want to spend time optimizing your software to get the most out of hardware, do it on the things that matter. Don't just do it to make it run. And so that's really our goal, is to have a set of software that basically everybody builds off of, the basic building blocks, right? And then from there say, okay, we have some special things in our silicon that we think will give you better performance for X, Y, Z reason. Let's go work on optimizing those things.
Can you give an example of how that would work?
I'm trying to think how I do this in a more generic. I probably won't give you specific customer examples that
Okay.
aren't specific, but
Well, you can-
I'll give you more generic. So we have a customer who wants certain features from power management, right? So they want to be able to have more fine-grained power management of their workloads. So they have certain workloads that they want to run at full performance, all out. They have a bunch of other workloads.
Is this on premises or for a cloud?
This is a cloud customer.
All right.
And so, but they have a bunch of other workloads that don't need that amount of CPU capability. So they want to be able to manage the power of those individual, all the way down to the individual server, all the way down to the individual core, as to what power they're actually going to need, or kind of what performance they're going to need for actual individual workloads.
I see.
And so, the ability to do that is something that we're, embracing with and saying, look, this is something that you can do with us that, frankly, is hard to do with, an Intel or an AMD that's trying to build one processor for everyone.
Right.
And that, that's one of the key things that, we think we can do. And, frankly, by having the depth of architectural knowledge that we do within our team, we can do those sort of things.
I see. And what about the on-premises person or DevOps, where they're looking to do the same thing actually as you just described?
Yeah.
And how would that play out? And please be as specific as you could.
Yeah. I mean, I think we see. So for us, kind of back up big picture. Our key focus area is cloud and edge. Is really the two markets that we're focused on to start with. And the reasons why, and this will kind of answer your question in a roundabout way, is one of the main reasons is the cloud customers have more control of their own software. So if a Google wants to go and move from one architecture to another, it's their own software. They don't have to go and license anything new. They don't have to go and convince another third party to rewrite an application. They can go and do that. So when you go to an enterprise, our engagements are really focused on customers that are like that, where they own their own software.
I see.
Right? So a DevOps team, like we've been talking to a number of big banks, for example, right?
Okay.
These big banks have a lot of their own applications. Now they also have like 3,000 other just random enterprise applications. That's not really our focus. Our focus is more about saying, look, you have a bunch of things that you really care about. I don't know, could be your financial modeling software. They've written that all themselves. Those are the sorts of opportunities that we're going after, because they can actually make that software move and then go and make the optimizations that they'll get benefit out of our architecture.
So you could maybe say that the bare metal opportunities you're providing are actually something that they can really distinguish.
Yeah.
How their applications just work.
Yeah. that's been a lot of our engagement with Packet, for example, right? So, Packet offers bare metal instances or bare metal servers. They'll do that. They offer as a cloud. They do that as on-prem, as well, or more kind of, smaller data centers, edge data centers, those sort of things. And a lot of the customers we've engaged with them on have been customers exactly like that. They understand what their workload is. They care a lot about what the hardware does. And they want to have kind of an intimate relationship with those providers. And those are large enterprises. That's not just cloud customers.
Yeah, true.
It's people though that are a lot of them have embraced the whole cloud native development model. And so for us, they kind of look and feel a lot like a cloud provider. They might be on-prem or they might be in a colo, but they don't operate like a traditional enterprise.
They're at that scale.
Yep.
I see.
And that's really, been our focus. And, while their applications might be different per se than, a Google or an Amazon or whoever it might be, the way they think about it is very similar.
Yeah.
And so, for us, it's just a different customer, might be a slightly different scale, but they have the same sort of programming models. They have the same sort of operational models. The way they think about hardware and the way they think about infrastructure is very similar.
Yeah. So it's no longer being completely dependent on the cloud, public clouds. This is a way, after you reach a certain point, a certain scale, where you can say, hey, I want to select the silicon, all the way down to the silicon.
Yeah. That's where we see. Like Packet's a great example of that. A lot of the customers we've engaged with have really had that, look, I want to understand and optimize my workload for my use case. And and if I'm that intimate with what I want to do, I need to go, a lot of them want to go down to the silicon level, and they want to, actually get into it and actually have ability to influence things we might do. And Packet is a great partner for that. In that, they've fully embraced that model. And that's actually where we align really well, is they want that kind of customer as well. They don't want just a customer that's just going to go to Amazon and say, I'll take whatever cheapest instance you have.
Right.
They want somebody who actually cares about the hardware and cares about the infrastructure and is going to partner with them.
Although these large cloud providers. Well, there's the Amazon
Yep.
conference going on
Yeah.
as we speak right now. Is one of the main things is you can select the silicon now, and there's an interesting fork here where you can select, for example, the processors you want on a bare metal configuration. If you're developing software with Amazon. So, but at the same time, so does everybody else. They have these same exact choices. So I think maybe what might become important in the future, it might trickle down a little bit, possibly, is where in general you'll have DevOps teams with limited on-premise environments be able to have much more of a choice. And they should, as far as distinguishing themselves.
And
Do you agree?
Yeah, I totally agree. I think you'll see more and more of that. I actually think the Amazon announcements about being much more invested in owning and developing their own silicon. I think you'll see that, and more than developing their own, offering more choice. I think that's actually perhaps the more important story. Is they're not doing this just because they were bored and wanted to do something really hard like make silicon. They saw that customers need choice, and the one size fits all just doesn't fit all. And so that's why they're investing, and not pre-announce anything, but I think you should assume that all the other cloud providers are looking at doing the same sort of things, right? They recognize that customers need this choice, and I think you see that they, even with the number of different offerings and services that they're offering, they see this. It's not I can just offer one compute instance and everybody's gonna be happy. That's definitely going to continue going forward. And I actually think it's going to continue even more into things like acceleration and offload, and that you're already seeing some of that in the cloud providers. I think that's just going to continue to grow in the kind of the heterogeneity of service offerings the cloud providers provide.
That makes sense. And going to what we were talking about before, taking a step back, how does the open source ecosystem play into these bare metal configurations, and even what you're doing down to the silicon level, or not? I don't know. What role does open source play?
I mean, I think open source is, for us, it unlocks that potential of more choice.
For example,
I'll give you good examples. VMware, for example, for many, many years, they were really kind of the only hypervisor for a long time, right? They would basically do all of their optimizations on one hardware platform, and that was all you could get. Open source hypervisors come along. You actually are now able to take these and run these on multiple different architectures. What we really see is the open source community has totally embraced a multi-architecture environment. And some of it is, it's good for their business, to be honest with you, to be able to sell software on every platform you can. But the other part of it is, I do think they recognize that there are, again, kind of needs for options. And the open source community also likes these sort of things, right? They like to embrace something new. They like to push the boundaries. The big thing for us, and why open source is so important, is pretty much all of the major building blocks that a customer would need if they're an open source customer have all embraced a multi-architectural environment, right? And so for us, really, if we had to be reliant on proprietary software and convincing, SAP and Microsoft and all of these proprietary software stacks to move on to a new hardware architecture, it's a very, very long journey. You go open source, and you just got to enable the community, and the community can move fast.
By definition, they're not locked in.
Right. And they're we found, much more willing to embrace opportunities, right? And new architectures, and be willing to say, this makes sense because, XYZ reason. And so for us, it is one of our key elements on why we think we can be successful. And really what's changed in the last, I want to say, just few years. I mean, this has been a long journey, but I think open source, you look at it, I mean, it is the foundation of pretty much every major customer we're going after today. And it's because of that software portability that you have now. It has made the software burden for us to get over much, much lower.
I mean, would you say that maybe the ARM architectures are more open source friendly than the Intel and the AMD x86s?
Good question. I guess I would say that they've kind of grown up that way. So I don't.
Who's grown up that way?
ARM has.
Yeah,
ARM's kind of grown up in the idea of, look, it's an open source world.
Yeah.
I mean, because you think about the types of things that ARM, not server related, but their historical business, where they have sold into, right? It has been IoT, embedded, mobile, low power, lots of different applications, lots of different operating systems.
Inexpensive.
Yeah, and so because of that, I think they've just naturally grown up with that
open source.
Yeah, and so they've embraced it. It's been much, much easier. I mean, the other thing is, the thing that ARM really benefits from as well is, the Dockers. I don't know if you've seen this, but Dockers has done quite a bit of announcement recently on ARM. And the reason why they're doing this is not just because they see the momentum in ARM server. They see it as, I want to write a Docker image once, and I want to be able to run that on everything from an IoT device that's sitting somewhere to a server.
Right.
And that has a lot of value in the open source ecosystem of, I can basically write this once and play everywhere, if you will, right?
I can think of another example of what Packet's doing with Tinkerbell.
Yeah. I'm not that familiar with all the details on that.
Well, apparently you can install or use Tinkerbell now, which has existed for a while, but they've open sourced it, where it should be, now you should no longer have to worry about when you buy a server or maybe thousands of server racks and IoT devices. As far as configuring goes, Tinkerbell does that.
Yeah.
And then you load the operating
whatever
system.
else you want on top of it.
It's a management system as well.
Yeah, I mean, I think you're going to see more and more of that kind of thing where it's, I want to be able to, I don't really want to have to go in and get deep into every detail of my software installation, right? I might care about the hardware it runs on because I want to get the optimal performance, but I don't want to have to write software for each individual device I'm running this on. Yeah. And so, like I said, I think that's one of the big advantages of the ARM ecosystem is it's billions and millions of devices every year that get sold, and people are developing software on this. And the more and more commonality you get in that software stack of, I can run this on an endpoint device to a server, has a lot of value for the open source community.
And as a silicon provider, I guess they're produced where at?
TSMC.
Like everybody else.
Yeah, pretty much.
And where would you say that your contributions to the open source community start? Or how would you characterize your contributions?
We do a number of different things. So there's a couple different foundations that we participate in. So there's Lenaro, there's OSI. There's I'm trying to think of the other big one we're involved in right now. There's all the LF Edge and Akrano stuff. So it really though is like 3 or 4 levels. So there's the community-based stuff where we'll be involved in. There's also individual projects where we'll work with companies, partners, et cetera. We've done a lot of stuff with OpenStack as an example, right? Where we'll actually work with the foundation or the open source organizing committee and actually put engineers into that. Or sometimes we'll contribute hardware to that. Sometimes we'll actually have people as part of the project. For example. Yep, exactly. So, and then the other things we'll do is people that have taken open source and done kind of the freemium or commercialized version and an open source, we might actually participate directly with those sort of customers.
I see.
And so it just kind of depends on where it is, but we're involved in all 3 of those levels.
Do you have engineers that are developing,
contributing
to specific open source projects?
Yeah, do you
have a favorite one yourself?
Oh God, I don't know. I've been doing a lot of stuff with the Akrano stuff. One of the things we've been trying to do a lot is edge applications. Yeah. A lot of really new, interesting stuff.
What do you find fascinating?
I think, the use cases are fascinating. Yeah. I think that's kind of, we've been doing stuff around AR, VR. One of the ones we've been doing a lot of stuff around is mobile gaming. That's another one that's kind of really interesting as an interesting edge application.
Yeah.
That's it's going to change the way gaming is done. I just think it's kind of a momentum shift. But yeah, I think, we're contributing to a lot of these. What I was going to say was, I'd say we're about 600 people. Our software organization's probably 150.
Yeah.
You wouldn't think,
engineers,
but you wouldn't think that as a silicon company, right?
Right.
Almost a quarter of our company's in software.
Well, it's kind of like Intel.
Yeah. I mean, Renee, our founder,
Right.
was the president of Intel. Before that, she ran the software and services organization at Intel. So she understands the importance of software in being successful in this market.
Where do you see it all going? I mean, you're involved in software development.
Yeah.
And there's been this explosion on the cloud, as everybody knows. And then there's this dynamic where certain companies that can scale are able to invest in on-premises and use people or companies such as Ampere to further differentiate themselves, which they couldn't do on the cloud. But where's it all going, would you say?
It's a good question. I mean, I think the big macro picture change or direction is a lot more variety in options. I mean, if you think about this, right? I mean, the cloud has really introduced a lot of different options and a lot of different services and a lot of different usage models. I personally think we're just kind of at the beginning of that. And I think you're going to see a lot more options in, not just 2 or 3 cloud providers.
Yeah.
There's going to be 2 or 3 probably big, large infrastructure to service partners. But there's going to be a lot more people that are going to go and deploy things at the edge. They're going to go deploy specialized clouds, automotive. There's going to be a lot more variety. And then in that, you're also going to end up with a lot more variety from a hardware and infrastructure perspective. Because when you start getting that diverse, it really, one size doesn't fit all. And so I think because of that, you're going to see, it's not just us as CPU vendors, things like acceleration and GPUs and, all these things, you're going to see those become much more mainstream as just the choice and the variety increases in the market.
Kind of a hybridization of maybe not on premises, but it's a cloud, private cloud, for example.
Yeah, I mean, it could be a private cloud. It could be, in an edge data center that's sitting at a cell phone tower because I have an application that has super low latency requirements. Like there's just gonna be more and more variety than I've just got, 20 gigantic data centers. Yeah, and it's gonna be a lot more variety. And so I think that's probably the biggest change that you're gonna see happening. And I think it's just gonna continue. I think we are at kind of a really interesting point at this point where those options are starting to become much more real across the entire landscape.
And maybe more accessible.
Yeah, I mean, more accessible,
for developers.
For developers, for end users, all of that. I think it is becoming a lot more common. And I think that's one of the biggest things you'll see.
Matt, wow, that was great.
Yeah, it's awesome.
Thanks for joining us.
Yeah, thank you very much. Great to be here, and hopefully the weather improves a little bit.
Yeah.
So,
and I hope you enjoy sunny Silicon
I
Valley.
will, for sure. All right, thank you.
Thanks.